This is Mrs. Wainwright's math class, Chapter 9, Lesson 4, Line Graphs. Today's learning target: by the end of the lesson, you should confidently be able to say, I can use a line graph to display and analyze real-world data. A line graph is a graph that uses line segments to show how data changes over time. Down here we have two examples of line graphs. Let's take a look at graph number 1 first. All line graphs have to have a title that go on top of the graph. Graph number 1's title is Accumulated Snowfall. The title tells you what the graph is about, so obviously this graph is going to be about snowfall that accumulated or fell and built up on the ground. Line graphs have both an X and Y axis. The X-axis is the horizontal axis. It goes from left to right. The X-axis always has a title. In this case, the title is day, so it tells us which day we're talking about. The title always lets us know what that is talking about, those labels. The X-axis also has each line of the graph labeled. Again, it's called a line graph, so it's not like a bar graph where you're labeling the spaces. You're actually labeling the lines. So notice here, for day 1, the 1 is labeling that line. And again, day 2, the 2 is labeling that line. Day 3, day 4, day 5, day 6, day 7, all the way down, each number labels the line since it's a line graph. All line graphs always have a y-axis, which is a vertical top to bottom axis or bottom to top axis that goes like this. All y-axes have a label that tells you what that information is. In this case, it's the snow level, how much snow accumulated or was built up on the ground. And it also has in parentheses the unit. So it says in feet. Therefore, I know the numbers stand for the amount of snowfall in feet. That's how many feet of snow they had. At the very beginning part of the graph, right where the X and Y axes meet, right here on this angle, the dot shows exactly where I'm talking about. That is called the origin. It's where all of the numbers originate from or start from, and that is always labeled 0. That corner must be labeled 0 each time on a line graph. And then just like the x-axis, for the y-axis, each line is labeled. Again, it's called a line graph, so it makes sense that each line is labeled. In this case, each line is labeled with a number, numbers 1 through 10. In graph number 2, we see that there's also the origin labeled 0, because the origin always needs to be labeled. And look at this y-axis. We skip the first line, the next line is labeled 4. They skip the next line, the line after that is 8. Skip a line, the line after that is 12. So notice that they skipped lines each time. If you're going to do that, you have to skip the same amount of lines all the way up. So you can't skip one and then not skip one, or skip one and then skip two. Either you don't skip them at all, or if you're going to skip one, it's always skipping one, or if you're going to skip two, it's always skipping two, but it has to be even intervals. In addition, in this graph number 2, notice the yellow arrows. Look at the numbers. It went from 0, 4, 8, 12. So in this graph, they counted by 4s. Therefore, the interval is counting by 4s. Again, if you're going to use an interval other than 1, you need to be consistent with the interval. So you can count by 2s, but the whole thing needs to be 2s. 2, 4, 6, 8, 10, 12. Or you can count by 4s or 5s or 10s, but you can't switch it up. Whatever you choose as your interval needs to stay your interval. So on a line graph, our next vocabulary word that we see highlighted on the top is scale. It says the series of numbers placed at fixed distances that label the graph or the graph's scale. So the scale for graph number 1 goes from 0 to 10. So that's our scale for graph 1, 0 to 10. The intervals, well, again, if you look at the numbers, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the intervals for graph number 1 are counting by 1. For graph number 2, the scale is from 0 to 12. And this graph, in graph number 2, the intervals, we counted by 4s, right? 0, 4, 8, 12 is counting by 4s. So let's take a look at example number 1. It says graph the data which is part A. That's the first thing I need to do. Notice there's no lines for me to graph the data, but it's telling me to do something, so I need to make sure that I do that. That's why I'll label it. And then it says use the graph to determine the times between which the greatest temperature change occurred. So I need to see between which times had the greatest temperature change when I look at the graph. That will be the second thing I need to do, which is part B. Notice it shows me the table. Right over here, the table has a title, recorded temperatures. That's the same title that I'll use for my graph. Then it tells me time in AM. The first thing that I see when I have a table will always be my x-axis. So I'll label this time in AM X, since I know that will be my x-axis. That labeled time, parentheses, AM, that is going to be the same label that I use on the x-axis in my graph. The next thing they give me says temperature in degrees Fahrenheit. This will be my y-axis. I remember this by the last three letters of the alphabet, X, Y, Z. The first one that I see will be my x-axis, then my y-axis. It's always the order that it goes in. Now, the label for my y-axis will be exactly what I see here on my table, temperature, parentheses, in degrees Fahrenheit. So my unit for each of them will be in the parentheses. And then on my table, it gives me the information. So for instance, remember the title is recorded temperatures. It tells me at 1 o'clock, which I know is AM, the temperature was 51 degrees. Notice on the right-hand side here, although it did not say it my highlighted information, there is another set of directions. It says write the related number of pairs as ordered pairs, and it has blanks. So I'll need to do that next. So again, I see that at 1 o'clock AM, the temperature was 51 degrees. They did that one for me. At 1 o'clock, it was 51 degrees. In an ordered pair, the x-axis goes first, the y-axis goes second. Again, remember X, Y, Z. So at 2 o'clock, it's 49 degrees. So I write down 2 o'clock, 49. That's my ordered pair. At 3 o'clock, it's 47 degrees. I write down 3 o'clock, 47. And so on and so forth. I go ahead and continue to write all of them down as my ordered pairs, all the way straight through to 7 o'clock and 46 degrees. Now that I have these parts done, I can go ahead and do part A, which says graph the data. When I make a line graph, I need to make it on graph paper. It needs to be paper with all these little graph squares on it. I need to remember that when I draw my X and my Y axes, I will need to be labeling them and putting a title on them. So I need to make sure that I give myself room on both the left side and on the bottom so that I can write down this information, because it must be included. When I make my X and Y labels, I need to use a ruler. It must be a ruler straight line, and the line must be exactly on top of the lines that are on the graph paper. If not, I need to erase it and fix it. So since it's very easy while you're working with a line graph to make mistakes, you should always work in pencil and nothing other than pencil for a line graph. Okay, so let's go ahead and draw our lines. I just drew my Y coordinate line, and now I'll draw my X coordinate line. Notice that they're right on top of the lines, they meet at a corner. I need to put arrows on the end of each side, and I need to label the origin, which is at the angle where both the X and the Y meet. Next thing that I need to put into my line graph is a title. It's very important because you lose lots of points if you don't have a title. So I'll go back to my table and see what the title is. And when I look back at the table, I see that the title is recorded temperatures. I'll use that same exact title. So title of a line graph gets written at the top of the graph. You should capitalize first, last, and all other important words. So the words that wouldn't get capitalized might be of, the, in, by, but pretty much every other word gets capitalized. And we should underline the title. One thing I notice when I'm looking here that I neglected to do is to label both my X and Y axes. So I'll write a Y by my Y axis and an X down here by my X axis. Now the first thing I'm going to fill in is my X axis. That's the left and right horizontal line at the bottom. I go back to my table to see what that information will be. And remember, I had labeled my X axis, here it is. So the name of that will be time. AM will be in parentheses. And I'll have the times 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, and 7 o'clock. So let's go back to my graph and put that in. Now for my x-axis, I never put a label on my y-axis portion of the x-axis. So right here where that line goes up, nothing will label that line. But I am going to label my other lines. Remember, this is a line graph, so I'll be labeling the lines, and I need to go from 1 o'clock to 7 o'clock. Let's see if I do every line, let's see if it fits. So for here, I usually take a pencil and just do a tiny little dot because I know I'm going to erase it afterwards. I'm going to make them a little bit bigger for you to see on this video. So if I did 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, I could fit everything, but it looks to me like I have a lot of space left over. So I wonder if instead I could skip lines. Let's check that out and see if that works. Even if I skip, I'll always start on the first line after the y-axis. So let's see if it worked. If I did 1 o'clock, skip a line. 2 o'clock, skip a line. 3 o'clock, skip a line. 4 o'clock, skip a line. 5 o'clock, skip a line. 6 o'clock, skip a line. 7 o'clock. Yes, everything would fit that way. So I think that will be my plan, and that's how I will label my x-axis. So I erase all those little tester pencil lines. It is important that I do that though. I need to plan out a graph. It does have to be properly labeled and properly set up. And I turn my paper sideways. You can't see me do that here, but I'm going to turn my paper sideways because it's important, especially on the x-axis, to label the lines and to not have your words or whatever your labels are going past the lines. If you turn your graph sideways, you can write it that way. So I have 1 o'clock on my first line, skip a line, 2 o'clock on the next line. See how it sits right on top of the line? Skip a line. 3 o'clock, skip a line. 4 o'clock, skip a line. 5 o'clock, skip a line. 6 o'clock, skip a line. And 7 o'clock. And now my title for the x-axis, according to that table, was time, and the unit was in parentheses, which was AM. So I have now fully labeled my x-axis. I'm ready to go ahead and label my y-axis. Let's look back at the table to see what I need for that. Okay, so when I look back at the table, I see that my y-axis, again, which I did label when I first looked at it, is temperature in degrees Fahrenheit. That will be my y-axis title. And I see all of the numbers, 51, 49, 47, 44, 45, 44, 46. I need to make sure that all of my numbers will fit in when I choose my scale and my interval. So the way that I do that is I look through all of the numbers to find my smallest number. And I see my smallest number is 44. I have two 44s, but that's still the smallest number. And I see my largest number is 51. So I know that I need to be able to fit within that scale the numbers 44 straight through to 51. I'll keep that in my mind as I'm planning out the y-axis. A few things to think about when you're planning out your y-axis. First, your origin is the 0 line, so that's always going to be 0. Next, if you can make your intervals by 1, that's the best. If 1 doesn't work, try 2. If 2 doesn't work, we usually jump to 5. If that doesn't work, we usually jump to 10. And if that doesn't work, we usually jump to 20. Sometimes there's another way to work it out, which we'll get to show you with this graph. So again, I use pencil so that I can erase it and I plan it out. I see my origin line is 0, so if the next line was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would never be able to get 44, which was my lowest number, or 51. So that's not possible. I cannot possibly count by ones. What about 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. It's not going to work by 2s either. Let's try 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That could work. I could do a 55 up there. But if I used 5s, watch where most of my data would fall into. If I used the interval of 5s, all of my data would fall into this big circled area up here, which is between the 44 and the 51. It would be very squishy, it would be very hard to see, and I wouldn't really be able to use the line graph to find out the information that I'm looking to find out. If I counted by 10s, that would be even worse. My lines would be up even closer together. So it'd be 10, 20, 30, 40, 50. All of my information would be in this tiny, thin little area right here. So what we're going to do, since all of our numbers are close together but much farther away from 1, is we're going to make a break. Let's watch and see how that's done. I can, in the space just above the origin, put a little break that kind of looks like a Z. And that kind of says we squish down that whole little area here because there's no data that's in that area. And then I can actually label with an interval of 1s. Usually when we start labeling our y-axis, we want to start with a number that's a little bit less than the actual lowest number we need and end with a number that's a little bit higher than the actual highest number that we'll need. So I know my lowest number is 44, so I'm going to start with 43. And again, we label the lines. So 43. Notice how I made that lay right on top of the line. 44, 45, 46, 47, 48, 49, 50. My highest that I need is 51, and I'll add one more past that, which is 52. So that tells me all of my data will be between 43 and 52. That's the scale that I used for this graph, 43 to 52. And since I counted by 1s, my interval was 1s. And of course my y-axis needs a title. So just like I turned my paper when I was labeling my x-axis, I need to turn my paper when I'm putting the title for my y-axis so I can write nice and neatly and in a straight line. And my title was temperature, and then in parentheses was the unit, which was in degrees Fahrenheit. That little circle is the degree sign. So I've set up my graph. I know all of my data will fit, and now I'm ready to go ahead and put the data into the graph. To put the data into the graph, I can use my ordered pairs. And remember, for your ordered pairs, X comes first, Y comes second. So my first ordered pair is 1 o'clock 51. If I don't have ordered pairs and the directions don't tell me that I have to do ordered pairs, I can also look right at the table, and I pretty much in the table see my ordered pairs, 1 o'clock 51 degrees. So let's go ahead and graph that into our line graph. So I find the 1 o'clock, and I don't use what I'm showing you in red. It's just showing you what I would do with my finger. So there should be no lines going straight up, only the dot that's plotted in. So at 1 o'clock I have 51 degrees, so I follow that 1 o'clock line all the way up to where 51 is, and that's where I put my dot. So this is what it looks like on the 1 o'clock line, and then the 51 degree line, my point is placed right there. Next I need to move over to the 2 o'clock and plot that data. So I can look at my ordered pairs or at my table, and I see that the next information I have is at 2 o'clock, it was 49 degrees. So I take the extra moment to make sure I'm exactly on the 2 o'clock line and not on a different one. I go up and I put my point at exactly 2 o'clock and 49 degrees. And again, I can look at my ordered pairs or my table to see at 3 o'clock it was 47 degrees. So I, with my finger, move straight up on the 3 o'clock line and put my dot in at 47 degrees. Go back to my data. At 4 o'clock is 44 degrees. So I make sure with my finger that I'm on the 4 o'clock line and put my dot in at exactly 44 degrees. Whether I look at ordered pairs or table, at 5 o'clock I see that it's 45 degrees. So I use my finger to make sure I'm exactly on the 5 o'clock line, and I put my dot at 5 o'clock and 45 degrees. Look back at my data, I see that 6 o'clock is 44 degrees. I double check that I'm on the right line, and I plot in my 6 o'clock 44. Go back to my table for my final ordered pairs. At 7 o'clock, it's 46 degrees. And again, I use my finger to be 100% sure I'm on the 7 o'clock line and put my dot in at the 46 degree mark. And now that I have completed plotting all of the points, this is a line graph. I need to connect the lines, and I must do this with a ruler. It needs to be ruler straight lines. I start at the very first dot that I plotted, and I connect dot to dot. You can't see my ruler, but I am using a ruler, so I start with my first to the second dot, second to the third, third to the fourth, make sure I'm going in order as I put them in. and connect all of the dots. So I now have this line graph that I can look at to find some information. And if I go back to my original problem, I completed part A, which is graph the data. So now I'm up to part B, which said use the graph to determine the times between which the greatest temperature change occurred. So I need to find the times between which the greatest temperature change occurred. And that is what a line graph does. It shows you changes in something. In this case, it would be changes in temperatures over time. To find the greatest change, since that's most often what you're looking for in a line graph, you look for the line that is the longest. Often this is whichever one has the steepest angle, which would be the closest to an up and down straight line. That's the section from point to point that would have the greatest change. So when I look at all of the different sections, I look at this one, this one, this one, this one, this one, and the last one. Which two dots are the furthest distance apart from each other? So which is the longest line with the steepest slope and the greatest change? I think it's this one right here. And the direction said between which two times, so I'll find those dots and look straight down. Again, I'm not drawing the red arrows, I'm just showing you where I look or where I use my finger to go down to, and I see that that line is between 3 o'clock and 4 o'clock a.m. So my final answer will be the greatest change in temperature is between 3 o'clock to 4 o'clock a.m. Notice that since the time label for my X unit said a.m., anytime you're talking about time, if they tell you a.m. or p.m., you need to include whatever it is in your answer. So this is my final answer. Please stop the video and complete worksheet number 1 right now. There are a lot of steps involved in a line graph, and every single one of them counts as points. So you should go back and make sure you do step by step with me. Do it together with the video as you go. Good luck with this problem. Let's take a look at example number 2. Jill used a rain gauge to collect data on the total rainfall during 6 days at her home in Miami. She read the amount of rain collected in the rain gauge each day and did not pour it out. Her data is shown in the table. Make a line graph to display Jill's data. Okay, so they have table right over here, and the title is Rainfall Collected. That will be the title of my graph. I see that the first information is day, and it has Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Remember, just like the end of the alphabet, X, Y, Z, the first information they give us will be my X-axis. The next information they give us will be my Y-axis. My Y-axis will tell me rainfall in inches. I see that it's telling me to write the related pairs of data as ordered pairs, therefore I must do that step. I see that the first data in the table says Monday there was 2 inches of rain, and I see they filled that ordered pair in for me, Monday 2. I'm going to go ahead and complete the rest of the ordered pairs. So I filled in Tuesday 2, Wednesday 3, Thursday 6, Friday 8, and Saturday 9. I'm done with my ordered pairs. I'm ready to start my line graph, which of course I do on graph paper. Remember, when making a line graph, I need room to the left of my y-axis and underneath my x-axis because I'm going to have to do labels and titles for those axes. I use a ruler straight line and go right on top of the line paper lines. So this is my y-axis and this is my x-axis. I'll put an arrow at the end and label x, an arrow at the end up here and label y. Remember, the origin is where the two lines meet. That is always the 0 starting point. I always think O or 0 for origin. Now I'm going to go back to my table to see what my graph title will be. My table's title was Rainfall Collected. That will also be my graph title. A line graph title gets written at the top of the graph and it gets underlined. Remember, first, last, and all other important words must be capitalized in the title. I'm ready to start graphing my x-axis, so I'm going to look at the x-axis right here, and I remember that it's days, and I have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, so let's go plan that out. Remember that I do not label my origin, which is my 0 line. I start labeling the line right after that. So again, I'm going to use pencil to plan it out. If I did Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, that would be great because I could fit everything in, but it would be very squishy and I have a lot of room left here. So let's try spacing it out again. And even if I'm spacing it out, that first line has to be labeled. So that's Monday, skip, Tuesday, skip, Wednesday, skip, Thursday, skip, Friday, skip, Saturday. Yep, that works perfectly. This is how I will label my x-axis. So remember, I'm turning the paper sideways and labeling right on top of the line so my label stays on the line. So Monday, skip, Tuesday, skip, Wednesday, skip, Thursday, skip, Friday, skip, and Saturday. I've labeled right on top of the lines since this is a line graph. And we said that the x-axis label or title was day. So I label it day. Now I'm ready to go ahead and figure out my y-axis. Look back at my table. Here is my y-axis, and I see the numbers 2, 2, 3, 6, 8, 9. I need to find the smallest and the largest. Smallest is 2, largest is 9. So my scale has to fit in the numbers between 2 through 9. Okay, let's go see what our interval should be. So if I start at the 0, I always want to see if a 1 works because that's the best. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's great. 2 through 9 will definitely fit if I use the interval of 1. So I erase those planning marks and I go ahead and write my numbers, sitting right smack dab on top of each line. That's my 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll do 1 extra since I have room, which is 10. Now I need the title for my y-axis. And when I look back at my table, I remember that the title was Rainfall in inches. And remember, you can't see me do this, but this is what you need to do, and it is what I am doing. When you're putting the title for your y-axis, you're going to turn your paper sideways so that you can write it nicely. Rainfall, parentheses for my unit, which is in inches. So I know that each number here is the amount of inches of rainfall. Okay, so I have my entire graph set up. Now I have to go ahead and put the data into the graph. Okay, so whether I'm using the ordered pairs or the table itself, I know that Monday had 2 inches of rain. So I find the Monday line, make sure I'm exactly on the line, and I graph the dot on 2 inches of rain. Remember, the red arrows that I'm showing you, you're not drawing in. It's just to show you how I would slide my finger up that line. My data says that Tuesday I also had 2 inches of rain in the container. So again, I slide my finger right up that Tuesday line to make sure I'm on the right line and put the dot at 2 inches. Look back at my table to see what I need to do for Wednesday. And according to my information, by the end of Wednesday there was 3 inches of rain. So I follow my finger up the Wednesday line and put the dot in at exactly 3 inches. Go back to my table to find out what Thursday is. By the end of Thursday, we had 6 inches of rain. So follow my line up on the Thursday and put my dot in at 6 inches. Then go back to my table and see what I have for Friday. When I look back at my ordered pairs or my table, I see that Friday had 8 inches of rainfall. Again, each and every time I use my finger, follow up the line, make sure I am definitely on the correct line, and plot in that 8. And I'll go back to the table one more time to find out how much rainfall there was on Saturday. And I see on Saturday there was 9 inches of rainfall. And again, use my finger because I do that every single time. Make sure I'm on the straight Saturday line and plot in the 9 inches. Now that I've finished plotting all of my points, I pick up my ruler again because I must connect my dots with nice ruler straight lines. I start from the first dot to the second dot with my ruler and keep going, each dot in order for nice ruler straight lines. So I've now finished drawing my line plot. I can go ahead and answer my questions. Question number 1 says, which day had the most rainfall? Remember, I am seeing which day had the most, so I'm comparing here. And in order to compare and find which one has the most change, I need to find the one that has the steepest angle, closest to a straight line, and I also can see which one seems like the longest of the lines. So if I look at each little line segment between the dots, I see this one, this one, this one, this one, and this one. Which one seems to be the steepest line, the longest line, and the closest to a straight line? I would say that it's this one right here. So if I look at the dots, I see that it's between Wednesday and Thursday, but it doesn't say which days, it says which day. So therefore I would take the second one, the last of the dots, which is Thursday. So which day has the most rainfall? The answer is Thursday. The next question says which day has the least rainfall. So if I'm looking for the day with the least rainfall, I'm looking for the day with the least change. And just like the most change is going to be the biggest line with the steepest angle, closest to a straight up and down line, well, the least would be the opposite of that. It's going to be the shortest line with the least angle, closest to the left and right side straight line. So I have all these choices to look at: this line segment, this line segment, this one, or this one. Which one shows the least change? It's not steep at all, and it's the most like a regular horizontal left and right line. It's definitely going to be this line segment. And this line segment falls between Monday and Tuesday, and it doesn't say between which 2 days, it just says which day. So if that's the case, we always pick the second one, so our answer would be Tuesday. So please stop the video and complete worksheet number 2 right now. Again, just like we said with number 1, a line graph has lots of information, lots of steps that you need to follow. So you should go back and complete it step by step as I completed mine using this video. Good luck with example number 2. Again, we will be continuing working on this and practicing this in class. And if you have any confusion or difficulties, please see a teacher. We will sit down and help you with this. Hopefully by now you can confidently say, I can use a line graph to display and analyze real-world data. Good luck with this lesson.